Life on Mars. Welcome to the History American podcast. We explore the stories that transformed the opinions of our citizens and shaped our collective memory. Here, we don't just narrate the past. We analyze and focus on the events that live on in the mind of America, a journey to the heart of the facts that defined us.
It's great to be here to dive into this.
Yeah, I'm so excited for this one. So, think about every science fiction movie you've ever watched. Like, we're always the ones looking up, right? Bracing ourselves, fighting off these alien invaders descending from the stars.
Oh, yeah. War of the Worlds, all of that.
Right, but I want you to imagine something with me for a second. Picture yourself stepping outside tonight, looking up at the night sky and finding that unmistakable glowing red dot just hovering in the darkness.
Mars always stands out.
It really does. And we've all looked up at Mars and wondered if there's life out there. But, well, what if we're asking the wrong question entirely?
How do you mean?
Like, what if the real question isn't whether there's alien life on that red world, but whether the very ancestors of humanity, like the origins of our own biology, might have actually started right there on that rusted rock billions of years ago?
Wow. Yeah, I mean, it is a profound, almost dizzying shift in perspective when you really think about it.
Right.
You go from looking at a distant alien world to potentially looking at a cosmic graveyard of our own distant origins. The idea that we are the aliens we've been terrified of all these years.
Yeah.
It fundamentally reorients our place in the universe.
And that is the absolute core of our mission for today's deep dive. We are pulling together a literal mountain of source material to really get to the bottom of our obsession with Mars.
There is so much ground to cover.
So much. We have breaking data from the National Aeronautics and Space Administration. We've got centuries of, frankly, deeply flawed astronomical history. And we have the most fiercely debated alternative theories about our solar system.
It really spans the whole spectrum of human thought.
It does. We're going to take you from definitive billion-dollar scientific breakthroughs all the way to the wildest, most fascinating corners of human imagination. Because to understand Mars, well, we have to look at the life and death of an entire planet.
And what makes this journey so compelling is how humanity's shifting understanding of Mars perfectly mirrors our own evolution as a species.
Oh, absolutely.
I mean, from ancient mythologies driven by primitive fear, to the dogmatic struggles of the Renaissance, right up to the razor-sharp technological precision we have in the modern era.
It's like a timeline of our own brains.
Exactly. Every single time we have pointed an instrument at Mars, we've essentially been looking into a mirror reflecting our capacity for wonder, our scientific progress, and, our deepest existential anxieties.
So true. Well, let's start right at the bleeding edge of that scientific progress, because the sheer technological power we have orbiting Mars right now is almost incomprehensible.
It's mind-blowing, honestly.
Let's talk about the Mars Reconnaissance Orbiter. This machine has been circling the red planet for 20 years now, just continuously hunting for the chemical and geological signatures of ancient water.
Yeah, but the way it looks at the planet is fundamentally different from anything that came before it.
How so?
Well, to understand the leap in technology, we really need to look at the optical power it possesses. There's an instrument on it called the High-Resolution Imaging Science Experiment.
Okay.
It's essentially a massive reflecting telescope, like the largest camera ever sent on a planetary mission.
Wow.
I mean, previous orbiters sent to Mars in the 1970s and 80s were revolutionary for their time, but they had severe limitations in spatial resolution.
Right, like they couldn't see the fine details.
No, exactly. They could only definitively identify objects on the Martian surface if they were roughly the size of a school bus.
A school bus.
Yeah.
Which, if you think about it, leaves a massive blind spot.
Oh, a huge one.
I mean, if you're an astrobiologist looking for subtle geological formations, maybe a dried up thermal spring or, sedimentary layers, a school bus resolution just gives you this blurry, pixelated mess. It's like trying to read a book from across the room without your glasses.
That's a great analogy. But the Mars Reconnaissance Orbiter's camera is so incredibly powerful that from orbit circling hundreds of miles above the surface at thousands of miles an hour, it can spot details as small as a dining room table.
Wait, a dining room table?
A dining room table.
That's crazy. You could set up a picnic on the surface of Mars and a satellite whipping around the planet in the vacuum of space could photograph it. That level of precision is terrifyingly impressive.
It really is. And that precision is exactly what has allowed scientists to completely rewrite the planet's history.
Because they're looking at the chemistry, right?
Right. They aren't just taking standard photographs. They're using spectrometers to analyze the light reflecting off the surface.
Okay, break that down for me.
So, different minerals absorb and reflect light at very specific, unique wavelengths. By analyzing those wavelengths, scientists can map out the exact chemical composition of the dirt.
So they can see exactly what kind of rocks are down there.
Exactly. They're identifying specific mineral deposits, like clays and sulfates, that, based on our understanding of chemistry, can only form in the presence of liquid water over vast periods of time.
So they aren't guessing. They know water was there.
They know it. They have mapped ancient seas, dried up lakes, river deltas, and this orbital mapping is what gave us the confidence to drop robotic laboratories right onto the most promising targets.
Which brings us perfectly to the Perseverance rover.
Yes.
It touched down back in February 2021. And because of that orbital data you just mentioned, it didn't just land randomly, right?
No, not at all. It was targeted at a very specific bullseye, Jezero Crater.
Right, and more specifically, a location within it called Cheava Falls. From what I understand, this is an outcropping of hardened mud sitting right alongside an ancient, dried-up riverbed. And here is where the data gets absolutely thrilling.
It really does.
The rover drilled into a specific rock, and it didn't just find evidence of water. It found something they called leopard spots.
Ah, yes, the leopard spots. This is where the chemistry gets deeply exciting for biologists.
What exactly are they?
Well, when Perseverance analyzed the core sample from Cheava Falls, it found these tiny, millimeter-sized off-white spots, and they are surrounded by black rings, which makes them resemble a leopard's coat.
Okay, so it looks cool, but what's in the rings?
The instruments revealed that those black rings contain iron and phosphate.
Iron and phosphate. Okay, why does an iron and phosphate ring matter so much to a biologist looking for aliens?
Because of how those rings form here on Earth.
Right.
When microscopic life, like bacteria or microbes, lives in rock, it uses chemical reactions to extract energy from its environment. On Earth, the specific chemical reaction that creates these iron and phosphate halos is almost exclusively driven by biology.
Wait, really? So it's like microbe footprints?
Basically, the microbes essentially eat and excrete, changing the local chemistry and leaving a permanent, mineralized fossil of their presence. It is a literal footprint in the rock.
So you have a rock sitting in a dried-up riverbed containing a chemical signature that, on our planet, is a flashing neon sign pointing to life.
Exactly.
The excitement in the scientific community has to be off the charts.
It is entirely unprecedented. There's a geosciences professor at Stony Brook University named Joel Hirowitz, who was a key member of the Perseverance science team.
Okay.
He has worked on Mars missions for over 2 decades. He's known as a very measured, cautious scientist. But regarding the Cheava Falls sample, he stated that this is the greatest certainty he has ever had about possible biosignatures in a Martian rock.
Wow, that's a huge statement from a cautious guy.
It is. In fact, he is so confident that he went on record saying it's, quote, better than a coin flip, end quote. He even offered to bet $20 right now that the rock contains biology.
I just love that image. A highly decorated scientist throwing a $20 bill on the table, betting on the existence of alien life.
It highlights how compelling the data is.
But of course, as always, the universe makes us work for it.
It certainly does.
The rover drilled the core sample. It sealed it up in this hyper-sterile titanium tube. But it's sitting on Mars. We can't put it under an electron microscope on Earth until we physically bring it back.
Right.
And the logistics of getting that tube back are currently turning into an absolute nightmare.
Right. This is where we run into the harsh friction between theoretical science and practical engineering.
Yeah.
The plan to retrieve these samples is called the Mars Sample Return Mission, and the mechanics of it are staggeringly complex.
Just walk us through what it actually takes.
Well, we have to send a spacecraft to Mars, land near Perseverance, deploy a fetch rover to collect the tubes, load them into a small rocket called the Mars Ascent Vehicle.
Okay, pause. A rocket on Mars.
Yes, and then launch that rocket off the surface of Mars, which is something humanity has never done. Then it has to rendezvous with an orbiter waiting in space, catch the sample container, and fly it back to Earth.
That is insane. You're talking about an autonomous, multi-stage rocket launch happening tens of millions of miles away, completely coordinated by robots.
Exactly.
If even one valve gets stuck with a grain of red dust, the whole thing fails.
And because the engineering tolerances are so impossibly tight, the estimated cost for this unprecedented feat has skyrocketed. It's sitting at roughly $11 billion.
$11 billion, wow.
Yeah, consequently, the mission is currently paused.
Which brings us to a massive defining moment of logistical friction within the United States government. It's a classic clash between massive scientific undertakings and changing government priorities.
It's a very complicated situation.
And I want to make it absolutely clear to you, the listener, right up front, that we take zero political sides here. We are just neutrally reporting on the friction between these massive science budgets and the current push for human spaceflight.
Right. We're just looking at the stated policy shifts.
Exactly. So, during Donald Trump's administration, the acting administrator of the National Aeronautics and Space Administration, Sean Duffy,
who, it's worth noting, also serves as the Secretary of Transportation.
Yes, thank you. Duffy addressed these findings directly. And he didn't dismiss the science at all. He actually acknowledged the sheer magnitude of the Chiava Falls discovery, stating that this rock might well be the clearest sign of life humanity has ever found.
He clearly recognizes the scientific value. But from a budgetary standpoint, the administration's stated priority is shifting deep space funding away from highly expensive robotic retrieval missions.
Right. They want to pivot hard toward crewed spaceflight.
Exactly. The primary goal is to put human astronauts back on the moon to build a sustainable presence and eventually send human crews directly to Mars.
So they want the rocks, but a multi-billion-dollar robotic fetch mission is incredibly difficult to justify when your primary mandate is building rockets for people.
Precisely. During a press conference, Duffy stressed that the agency is actively looking for, quote, cheaper and faster, end quote, ways to retrieve the samples.
Which means leaning on commercial space partners, I assume?
Yes, hoping for innovative solutions, though the specifics of how that will actually be achieved remain undefined right now.
Right.
Meanwhile, Nicola Fox, the Associate Administrator for the agency's Science Mission Directorate, added a very necessary note of caution.
What does she say?
She reminded the public that while the rover's findings are incredibly compelling, they are not a definitive conclusion. Without an Earth laboratory, we simply cannot say with absolute certainty that we have found life.
And while the United States restructures its budget and searches for a cheaper method, there's a massive global ticking clock running in the background.
Yes, the International Space Race.
The Chinese Space Agency is actively moving forward with their own robotic sample return mission called Tianwen-3. They're planning to launch in 2028 with the explicit goal of bringing Martian rocks back to Earth by 2031.
The scientific and geopolitical stakes could not be higher right now.
So the very first pieces of pristine Mars dirt to be studied in a modern laboratory might not even land in the United States. It's like finding a locked treasure chest in the middle of a blazing, impassable desert.
A very expensive desert.
Right. You have the map, you found the chest, you can even peek through the keyhole and see the gold shining inside. But right as you reach for it, you realize you don't have the funding for the helicopter you need to airlift the chest back to the lab to open it. It is agonizing.
It really is the ultimate scientific cliffhanger. The treasure is secured, sitting in a titanium tube on the dirt, but stranded.
So, okay, how did this treasure chest get buried in the desert to begin with? I mean, if there were microbes swimming around leaving leopard spots in the mud, what happened to the water?
That is the big question.
Let's dial the clock back. Way back. Take us back 4.5 billion years. Earth and Mars are essentially siblings, born in the exact same stellar nursery, right?
They are. Both planets coalesced from the swirling accretion disk of gas and dust surrounding our young sun roughly 4.5 billion years ago.
Okay.
And crucially, both formed within what astrophysicists call the habitable zone.
The Goldilocks zone.
Exactly. This is the orbital sweet spot around a star where the ambient temperature is neither too hot to boil water away, nor too cold to freeze it solid.
So water can just pool on the surface?
Yes, it allows liquid water to pool stably. And we know definitively, through the chemical signatures we just discussed, that around 3.5 billion years ago, Mars had abundant liquid water, oceans, rivers, and a thick, protective atmosphere.
So if they started with the exact same basic ingredients, sitting in the exact same relative neighborhood, why is Earth this vibrant blue marble teeming with complex life, and Mars is a frozen, rusted wasteland?
It's tragic, really.
How does a whole planet die?
It comes down to planetary scale and the mechanics of internal thermodynamics.
Break that down for me.
Mars is about half the size of Earth, and significantly less dense, because it's smaller. Its internal molten core cooled down much, much faster than Earth's did.
Okay, so it just got cold inside. Why does that matter?
Because a planet's spinning liquid iron core is critical for survival. The convection, the churning of that molten metal deep underground, acts like a massive dynamo. It generates a planet-wide electromagnetic field.
Ah, and that magnetic field is the invisible shield that protects us from the sun.
Precisely. The sun is not just a source of light. It constantly blasts out solar wind, which is a lethal, high-velocity stream of charged particles and radiation.
Right.
Earth's magnetic field acts like a deflector shield, bouncing that radiation away so our atmosphere remains intact. But when Mars's core cooled down, or, as some astrophysicists theorize, after a massive planet-cracking asteroid impact disrupted the internal convection currents about 4 billion years ago, that magnetic dynamo simply shut down.
Oh man, the invisible shield just dropped.
Completely dropped. The entire planet was completely exposed to the brunt of the sun.
That is terrifying to picture. What happens to the air when the shield drops?
Without the magnetic field, the solar wind slammed directly into the Martian atmosphere. The physics of this process is called sputtering.
Sputtering?
Yeah. The high-energy particles from the sun act like microscopic billiard balls, colliding with the molecules in the upper Martian atmosphere and literally knocking them off into dim space.
So it's just stripping the air away molecule by molecule.
It's a slow process, but over millions of years, the radiation stripped the atmosphere away entirely. As the atmospheric blanket thinned out, the pressure on the surface dropped.
And without air pressure, water boils, right?
Exactly. Without pressure, liquid water cannot exist. The oceans began to boil off into vapor and were subsequently blown away by the solar wind. By roughly 3 billion years ago, the vibrant world had died, leaving behind a frozen desert.
And the red color, the iconic rust that makes it so visible in the night sky to us.
That is the final signature of its death. The surface of Mars is incredibly rich in iron. As the oceans evaporated and the atmosphere thinned out, the iron rocks on the surface interacted with the trace amounts of oxygen left in the decaying atmosphere.
It oxidized.
Yes. The entire planet literally rusted, giving it that vibrant, bloody red hue.
It is so wild to think about how that rusted, dead world captivated ancient humans long before anyone ever even had a telescope.
They had no idea what it actually was.
Right. They didn't know about core cooling or solar wind sputtering. They just saw this glowing red eye drifting through the dark. And because it was red, it bypassed logical thought and tapped right into our primal psychology.
The color of blood.
Exactly. It became this universal symbol for blood, fire, and conflict. I mean, the ancient Egyptians, roughly 4,000 years ago, tracked its unpredictable movement across the desert sky and named it Horus the Red after their powerful sky god.
The Babylonians had a similar reaction.
Yeah, they looked up and named it Nergal, their deity of conflict, destruction, and scorched earth. The Greeks, of course, named it Ares, their god of war.
It's universal.
It's like the planet's tragic, violent geological death cast a psychological spell over human history from tens of millions of miles away.
It truly did. It was an object of fear and reverence. But the Greeks didn't just use Mars for mythology. They eventually used it to try and understand the mechanical structure of the universe itself.
Oh, right, Aristotle.
Yes. In 357 BC, the renowned philosopher Aristotle was observing the night sky and witnessed a specific celestial event called an occultation.
What's an occultation?
He watched as the moon passed directly in front of Mars, temporarily blocking the red planet from view.
The ultimate cosmic photobomb.
Exactly. But Aristotle used that simple observation to deduce a fundamental spatial truth. If the moon can physically block Mars, the moon must be closer to us than Mars is.
Which is brilliant logic for 300 BC.
It was. This simple deduction led Aristotle to organize a comprehensive map of the solar system. However, based on human intuition, he placed the Earth dead in the center, with the moon, the sun, and the planets, including Mars, orbiting us in perfect concentric circles.
The Earth-centric or geocentric model, which makes total intuitive sense when you're standing on the ground feeling zero motion, watching everything else move across the sky.
It feels like we are stationary.
Right. And this model didn't just stick around for a few decades, it locked in for centuries. It became deeply intertwined with Judeo-Christian theology, matching biblical verses that proclaim the Earth was firmly established and could not be moved.
It transitioned from a philosophical theory into unassailable religious dogma.
And to challenge the Earth-centric model was to challenge the divine order of creation.
Exactly. It took nearly 2 millennia, until 1543, for a brilliant Polish astronomer and mathematician named Nicholas Copernicus to finally shatter that model.
Enter the heliocentric model.
Yes. Using advanced geometric calculations and meticulous tracking of planetary movements, Copernicus proved mathematically that the planets, including Earth, circle the sun.
But there was a massive glaring mystery that the old Earth-centric model struggled to explain, and I want you to explain this because it's so vital to understanding how we finally cracked the mechanics of the solar system.
You're talking about retrograde motion.
Yes. The mystery of retrograde motion. Sometimes ancient astronomers would watch Mars night after night and it looked like the planet stopped, put it in reverse, moved backward across the sky for a few weeks, and then started moving forward again.
It really confused early astronomers.
Why does a planet look like it's driving in reverse?
Well, to understand retrograde motion, we have to look to another brilliant astronomer, Johannes Kepler, born in 1571.
Okay.
Kepler took Copernicus's sun-centric model and made a crucial mathematical adjustment. He realized the planets don't orbit the sun in perfect circles, they orbit in oblong elliptical shapes.
Like ovals.
Right. Because of this, planets travel at different speeds depending on their distance from the sun.
Okay, let me try an analogy here to visualize this for the listener. It's like two race cars on oval tracks.
I like that.
Earth is on the inside track, closer to the sun, so we are moving much faster. Mars is on the outside track, moving slower. In fact, Earth laps the sun twice in the time it takes Mars to go around just once.
That's correct.
So when Earth comes speeding up from behind on the inside track and passes Mars, it creates a massive optical illusion from our perspective in the driver's seat.
Exactly.
For those few weeks as we speed past, if we look out the window at Mars against the backdrop of distant, stationary stars, Mars looks like it's falling backward, going in reverse.
That is a perfect visualization. It is a purely optical illusion caused by relative orbital speeds. But proving that Earth was just another race car on a track and not the divine immovable center of the universe, it created seismic cultural shockwaves.
I mean, it fundamentally shifted the power dynamic of human knowledge. Copernicus knew his heliocentric model threatened the absolute dogma of the Catholic Church.
He was acutely aware of the danger.
He was so terrified of the repercussions that he phrased his findings as a quote-unquote hypothetical mathematical scenario. He even dedicated his book to the Pope just to avoid persecution. He literally waited until he was on his deathbed to publish it.
And while Copernicus avoided direct persecution by dying, the precedent was set. Scientists began pushing boundaries, building better telescopes, observing the moons of Jupiter and the phases of Venus.
All of which proved Copernicus right.
But the Church pushed back brutally to maintain its authority. Scientists like Giordano Bruno were burned at the stake for proposing the universe was infinite.
Burned at the stake for astronomy, that is so dark.
It was a very dangerous time to look up. In 1616, the Catholic Church officially banned Copernicus's book altogether and eventually placed Galileo under house arrest for the rest of his life. The battle to understand Mars and our place in the cosmos was quite literally a matter of life and death.
We look at the stars now with such casual curiosity, completely forgetting the blood spilled just to prove that we orbit the sun.
It's easy to take it for granted now.
But as the telescope improved and the Enlightenment took hold, the danger of looking at Mars shifted from religious persecution to something entirely different, our own desperate desire to not be alone in the dark.
Yes, the search for neighbors.
Which brings us to 1659 and a massive pivot in our understanding. A Dutch astronomer named Christian Huygens points his newly designed refracting telescope at Mars.
Huygens was looking through what was, at the time, cutting-edge optical technology. He used specialized lenses to magnify the planet, and he spotted a massive, distinct dark spot on the Martian surface.
Do we know what the spot was?
Yes, it's a region we now call Syrtis Major. But given the Earth-centric bias of the era, he naturally assumed this vast dark area was a body of water, an ocean.
Of course. Dark means water.
But more importantly, by meticulously tracking the movement of that spot as the planet rotated, Huygens calculated the length of a Martian day. He clocked it at roughly 24 hours and 40 minutes.
which is almost identical to Earth.
It's incredibly close.
If you're an astronomer in 1659 and you find a planet right next door with vast oceans and the exact same day-night cycle as your own home, you are absolutely going to assume there is life down there waking up with the sunrise just like you do.
It was a very logical, data-driven conclusion based on the incredibly limited tools available at the time.
Sure, it makes total sense.
But the true turning point, the moment that permanently altered humanity's perception of Mars for an entire century, came in 1877, thanks to a massive historical translation error.
This is one of my absolute favorite historical blunders. Please set the stage for us.
So, an esteemed Italian astronomer named Giovanni Schiaparelli was observing Mars from his observatory in Milan during a period when Mars was exceptionally close to Earth.
Okay.
He was meticulously mapping the supposed seas and continents. But as he strained his eyes through the eyepiece, he also noticed a network of long, straight lines connecting these large bodies of water.
Straight lines.
Right. In his notes and his published maps, he labeled these dark lines using the Italian word canali.
Now, canali in Italian translates to channels or grooves, right?
Yes. It implies a naturally occurring geological formation, like a canyon or a riverbed carved by erosion.
It's purely descriptive for a natural feature.
Exactly. But when his maps were distributed across Europe and the United States, English translators rendered the word canali as canals.
And canals mean something entirely different to an English speaker.
A very different implication.
A canal is a man-made structure. It implies intent, it implies heavy engineering, and context is everything here, right? This was happening right around the time human civilization was executing massive terraforming projects of our own.
The timing was perfect for a misunderstanding.
We had just finished building the Suez Canal in 1869, connecting the Mediterranean to the Red Sea, and we were actively planning the Panama Canal. So the general public looks at these translated maps and thinks, my God, there's an advanced civilization on Mars doing exactly what we're doing, but on a planetary scale.
The translation error acted as a spark in a powder keg of public imagination. It gave scientific credence to the idea of an advanced alien race.
And no one was more captivated or more obsessed than an American author and wealthy businessman named Percival Lowell.
Lowell was deeply invested.
Completely. In 1894, entirely driven by this romantic idea of Martian engineering, Lowell spent his own personal fortune to build a state-of-the-art observatory on a high-altitude peak in Flagstaff, Arizona.
Specifically to study these canals away from the light pollution of the cities.
Right. And Lowell didn't just look through his telescope and say, yep, those are canals. He created an entire, incredibly detailed cinematic universe in his head.
He built a whole mythology.
He published elaborate, highly detailed theories claiming that Mars was a dying, rapidly drying planet. He believed that a desperate, highly intelligent race of Martian aliens had built this massive planetary canal system to pump melting water from the polar ice caps all the way down to the equator to save their dying cities.
It was an incredibly compelling narrative.
He wrote multiple best-selling books about it. He gave lectures. The public completely devoured it. He essentially invented modern science fiction right then and there.
The problem, of course, was that many other highly respected astronomers of the era looked through their own equally powerful telescopes and saw absolutely no straight lines.
So it was just him seeing it?
Essentially, yes. So the scientific community had to ask, why did Lowell see such intricate, intersecting, perfectly straight lines?
Did they figure it out?
They did. Modern science has a fascinating biological explanation for this, and it has absolutely nothing to do with aliens. It's called the entoptic phenomenon.
I love this explanation because it is so incredibly human. Please break down the anatomy of what the entoptic phenomenon actually is.
To understand it, you have to look at the anatomy of the human eye. The light-sensitive layer at the back of your eye is called the retina.
Okay, for retina.
However, the blood vessels that supply oxygen to your eye actually sit in front of the retina, right in the path of incoming light.
Wait, so there are veins blocking our vision?
Technically, yes. But usually, your brain simply edits these blood vessels out of your vision the same way you don't notice your own nose.
Oh, that makes sense.
But when a human eye stares intently into a bright, intensely focused source of light with a very small exit pupil, like the eyepiece of a powerful 19th century telescope for a prolonged period, it can experience a strange visual feedback loop.
What happens?
The intense light bounces around inside the eye and casts shadows of those capillary blood vessels directly onto the retina. The observer's own circulatory system is essentially projected into their field of vision.
Wait, so you're telling me that Percival Lowell, this brilliant, wealthy man who built a whole observatory on a mountain, was staring so hard and for so long at a blurry red dot that he was literally drawing maps of the microscopic veins in his own eyeball?
That is the leading scientific consensus on what happened to him.
And he published them as the dying, sprawling cities of a Martian civilization.
Yes. The canals he mapped bear a striking resemblance to the capillary network of a human retina. He was mapping himself.
That is both incredibly tragic and incredibly hilarious. But it really shows how desperately we wanted to find someone else out there. We were projecting our own biology onto the stars.
It's a very human mistake to make.
And this obsession didn't just grip eccentric billionaires, it gripped the absolute greatest, most brilliant minds of the era. I mean, we aren't just talking about authors. Let's talk about the inventors who tried to literally phone the aliens, like Nikola Tesla.
Yes, Nikola Tesla, one of the greatest electrical engineers in history. In 1899, Tesla was conducting highly advanced experiments with a massive magnifying transmitter for wireless telegraphy.
This was at his lab in Colorado Springs, right?
Correct, up in the high-altitude hills. Late one night, while monitoring his equipment, his receiver picked up a highly unusual electrical signal.
What did it sound like?
It was 3 distinct, rhythmic, soft taps. Tap, tap, tap. Tesla was convinced this was not a natural atmospheric phenomenon like lightning or static. He believed it was a mathematically coded message.
And because the signal was weak and rhythmic, he reasoned it had to be coming from an immense distance.
Right. He initially considered Venus or Mars, but given the massive cultural obsession with Lowell's Martian canals at the time, he actually locked onto Mars.
And he went straight to the press, didn't he?
He did. He leveraged his massive reputation and told the world he had intercepted a broadcast from a Martian civilization.
And the media went absolutely wild. They called anyone who doubted Tesla an anti-intellectual donkey holding back human progress.
And Tesla wasn't alone in this conviction either. In the 1920s, Guglielmo Marconi, the man credited as the pioneer of long-distance radio transmission, claimed his own highly sensitive receivers in London and New York were picking up persistent, Morse code-like signals originating from deep space.
Even Albert Einstein weighed in on the frenzy.
That's right. While Einstein was too rigorous a physicist to confirm the radio signals were definitively alien, he stated confidently to a reporter that there was every reason to believe Mars was inhabited.
He really said that.
He did. Furthermore, he suggested that if we truly wanted to communicate with them, we were going about it the wrong way. He proposed we should use highly controlled light waves instead of radio waves, as light would cut through the vast distances more effectively.
Which directly inspired a guy named Elmer A. Sperry to come up with one of the most absurd comic book engineering proposals I have ever heard in my life.
Sperry was an interesting character.
He was a prolific inventor with hundreds of patents, particularly in searchlight technology. He read Einstein's advice and decided to act on it.
What was his plan?
He proposed building a colossal terrestrial light reflector. He wanted to combine 200 massive naval searchlights to generate a single beam with a staggering 1 billion candle power brightness.
1 billion candle power.
Yeah. He wanted to flash this billion candle power flashlight at the night sky like a cosmic bat signal so the Martians would see it and flash back.
This is an incredible image.
The only reason he didn't build it is because he couldn't find investors willing to pay for the astronomical amount of electricity required to power the thing.
It sounds like pure science fiction today, but the belief in Martian neighbors was so pervasive and culturally ingrained that it eventually reached the highest levels of the United States government and military.
Wait, the military got involved?
Yes. In August of 1924, Earth and Mars experienced an opposition.
What exactly is an opposition?
It is a celestial event where the two planets align on the exact same side of the Sun, bringing them exceptionally close to one another in their respective orbits, roughly 36 million miles apart.
Okay.
It is the shortest possible distance for a radio signal to travel between the two worlds.
Ah, so it's the perfect time to listen for a signal without interference.
Exactly. The Secretary of the Navy at the time, Curtis Wilbur, took the possibility of intercepting a Martian broadcast so seriously that he ordered a complete national radio blackout.
A blackout?
Yes. All United States naval stations were ordered to maintain strict radio silence. They tasked their top cryptographers to sit in quiet rooms, headphones pressed to their ears, monitoring the open channels.
Just waiting to translate any unusual rhythmic intergalactic transmissions.
That was the goal.
Just imagine that tension. The entire U.S. Navy sitting in total silence, staring at their receivers, waiting for the Martians to say hello. And, well, what did they hear?
Absolute silence. Nothing but the random hiss of cosmic static.
The great Martian silence. It's almost heartbreaking.
It really was a turning point.
And before we dive into how we finally shattered these grand illusions by actually sending machines to touch the Martian dirt, I have a quick favor to ask you, the listener. We love pulling together these massive multi-century narratives, but diving this deep into the archives, reading the scientific papers, and synthesizing the physics takes a colossal amount of research and time. If you're enjoying this journey to the Red Planet, please consider supporting the deep dive. There is a PayPal link located right in the description below. Your support is exactly what allows us to keep digging through the history books and bringing these massive stories to life. Thank you so much for being part of this exploration with us.
All right, let's get back to it. We've spent centuries projecting our own hopes, fears, and biological quirks onto Mars. When did the hard reality finally hit us?
Reality hit like a ton of bricks in November 1964 with the launch of the National Aeronautics and Space Administration's Mariner 4 mission. So we finally sent a camera.
We were finally done guessing with terrestrial telescopes. This was a robotic flyby mission designed to hurtle past the planet and finally get a close look. On July 14th, 1965, Mariner 4 flew past Mars and snapped 22 digital photographs of the surface, beaming the telemetry data back to Earth.
And when the scientists printed out those 22 photos, what did they actually show?
Unmitigated devastation.
Wow.
The scientific community had held out hope for vegetation, or at least sprawling oceans. Instead, the images revealed a desolate, heavily cratered terrain that looked terrifyingly similar to our own dead moon.
No oceans.
No oceans. There were no dying cities. And, unequivocally, there were no canals. Furthermore, the atmospheric instruments on Mariner 4 measured the density of the air.
What did they find?
The data showed a staggeringly thin atmosphere, mostly carbon dioxide, with surface temperatures plunging to minus 64 degrees Celsius.
Minus 64? That is brutal.
It was a freezing, irradiated, toxic wasteland. The romantic, century-long dream of an advanced Martian civilization was shattered instantly.
The disappointment must have been crushing for everyone who believed in it. But just as the massive door closed on little green men sailing canal boats, a tiny, microscopic window opened for something much smaller, but arguably much more profound.
The meteorite.
Yes. Let's pivot to December 1984. A team of scientists is scouring the blue ice fields in Antarctica, and they find a 4-pound rock. A meteorite officially named AH 8400.
This specific meteorite is a crucial, undeniable piece of the planetary puzzle. When scientists placed this 4-pound rock into mass spectrometers and analyzed its chemical composition, the trapped gases inside the rock perfectly matched the exact atmospheric and chemical signatures recorded by the satellites orbiting Mars.
But wait, how does a 4-pound rock get from the surface of Mars all the way to an ice field in Antarctica?
The mechanics are extremely violent. Millions of years ago, a massive asteroid slammed into the surface of Mars. The kinetic energy of that impact was so immense that it blasted chunks of the Martian crust upward with such velocity that they achieved escape velocity. They completely broke free of Mars's gravitational pull.
So they just became their own tiny asteroid.
Yes. This specific rock floated through the vacuum of space for millions of years before its trajectory intercepted Earth's orbit, and it crashed into the Antarctic ice roughly 13,000 years ago.
So it definitively proved that pieces of Mars could naturally travel to Earth. But the real bombshell, the moment that stopped the world, dropped in 1996.
That was a massive announcement.
Scientists put a slice of this Martian rock under high-powered scanning electron microscopes, and inside the fractures of the rock, they saw something impossible. Tiny fossilized worm-like structures.
Right.
They also found magnetite crystals and carbonate rosettes, which on Earth are often produced by biological organisms. They looked exactly like fossilized bacteria.
It was a monumental announcement. The President of the United States even gave a press conference about it. However, the scientific method requires rigorous, almost brutal skepticism.
So what did the skeptics find?
Over the following years, biogenetic experts and geologists relentlessly analyzed the data. They concluded that these worm-like structures, while visually similar to bacteria, were simply too small.
Too small to be alive.
Based on our fundamental understanding of biology, yes. They did not possess enough physical volume to contain the molecular machinery, the ribosomes, the DNA, the RNA required to sustain life. They eventually proved that non-biological geological heating processes could create the exact same crystalline structures.
So no definitive fossilized aliens in the rock.
No, unfortunately not.
But the debate itself proved one massive point. We couldn't just fly by the planet anymore, and we couldn't wait for meteors to fall to us. If we wanted the truth, we had to go there. We had to touch the surface.
Which is incredibly dangerous.
Right. And that brings us to the rover era, which is basically an era of terrifyingly expensive high-stakes gambles.
That is an incredibly accurate description. Landing on Mars is one of the most difficult engineering challenges in human history. Historically, space agencies face a 70% failure rate when attempting to land on the red planet.
70%? Why is it so hard? Why do they call it the 7 minutes of terror?
Because the Martian atmosphere is a cruel paradox. When a spacecraft arrives, it's traveling at roughly Mach 20, over 12,000 miles an hour.
That's incredibly fast.
It is. Now, the atmosphere is thick enough that the friction generates thousands of degrees of heat, requiring massive heat shields to prevent the craft from incinerating.
Okay, so it burns.
Right. However, the atmosphere is also too thin to provide enough aerodynamic drag to slow the craft down using just parachutes. It's not thick enough to catch you, but it's thick enough to burn you up.
That is a terrible combination.
It's the worst. So the craft has to autonomously deploy a parachute at supersonic speeds, then drop the parachute, ignite retro-rockets to slow descent, and use complex systems like airbags or sky cranes to gently lower the rover to the ground.
And all of this happens in just 7 minutes.
All of it. Completely autonomously because the radial delay to Earth is too long for human pilots to intervene. It either works perfectly or you create a multi-million-dollar crater. Missions have burned up, crashed violently, or inexplicably lost communication seconds after touching down.
But in 1997, we tried again with the Pathfinder mission and the Sojourner rover. I love Sojourner.
It was a huge milestone.
It was tiny, basically the size of a microwave oven, weighing just 25 pounds, creeping along on 6 little wheels. They expected it to survive in that harsh, freezing environment for maybe 7 days before the abrasive Martian dust covered its solar panels and chunked its battery.
But Sojourner defied all engineering expectations. It operated for 83 days, sending back hundreds of images from the ground level and using an alpha-proton X-ray spectrometer to analyze the chemical composition of the rocks and soil.
83 days instead of 7? That's incredible.
It proved definitively that mobile, autonomous robotics on Mars were viable.
Which gave the agency the confidence to greenlight a massive $800 million gamble in 2003. 2 much larger rovers launched at the same time, Spirit and Opportunity.
They were much larger, roughly the size of golf carts.
And when Opportunity landed, it found something bizarre sitting in the dust that fundamentally changed our understanding of Martian history. Blueberries.
Yes, the famous Martian blueberries. As Opportunity rolled across a region called Meridiani Planum, its cameras captured thousands of tiny, perfectly spherical, iron-rich stones scattered across the surface.
Wait, like little metal marbles?
Exactly like scattered marbles. And while they look peculiar, geologists know exactly how they form. They are called hematite concretions.
And how does a rock form into a perfect sphere?
On Earth, these exact spherical concretions only form underground when highly acidic, iron-rich groundwater flows through porous sedimentary rock.
Okay, so water has to be flowing through it.
Yes. As the water evaporates, the iron precipitates out and crystallizes into perfect spheres. Over millions of years, the softer surrounding rock erodes away, leaving the hard iron spheres scattered on the surface.
So finding them on Mars
was absolute, undeniable chemical proof that the planet's surface was once soaked in flowing liquid water.
So we proved the water existed, we mapped the dried up rivers, and now, as we discussed at the very beginning with the Perseverance rover and the leopard spots, we are hunting the actual microbes that lived in that water.
The search continues.
But looking to the immediate future, we aren't just satisfied with sending robots anymore. The ambition has scaled up to science fiction levels. Elon Musk and his company SpaceX have planted their flag.
A very ambitious flag.
Very. Musk has stated very public ambitions to launch a crewed human mission to Mars as early as 2026, and he wants to build a self-sustaining city of 1 million people by the year 2050.
That's a massive undertaking.
He claims it will require a massive fleet of 1,000 specialized rockets launching constantly.
It is a vision of unprecedented, almost staggering scale. But if we separate the inspiration from the engineering, We have to apply a rigorous reality check to the logistics of surviving on the Martian surface.
Right. It's not just camping.
No, it is not as simple as landing a rocket and pitching a tent. The environment is actively hostile to human biology. First of all, the soil itself is inherently toxic.
Wait, I thought the soil was just oxidized iron dust. How is it toxic?
The dirt is heavily laced with chemical compounds called perchlorates.
Perchlorates?
Yes, they are chlorine-based salts. On Earth, they are highly toxic to human beings. They interfere with the thyroid gland, disrupting hormone production and metabolism.
So you can't touch it.
If a human were to ingest Martian dust or even inhale it continuously as it gets tracked into the habitat on spacesuits, it would be severely detrimental to their health. Which means you cannot simply plant seeds in the dirt and grow food.
So agriculture right on the surface is out. You can't just throw potatoes in the dirt like Matt Damon in the movies. What do we do?
To survive the radiation and farm safely, human colonists would likely need to build massive subterranean structures or heavily shielded, pressurized greenhouses on the surface.
And they'd have to clean the dirt.
They would have to chemically wash the perchlorates out of the soil before using it for agriculture. Furthermore, 1 million people require a vast, continuous supply of water.
You can't just ship water from Earth.
Transporting millions of gallons of water from Earth is economically and physically impossible due to weight limits on rockets. Therefore, the colonists would have to establish massive, heavy industrial operations to mine and melt the subterranean ice or the polar ice caps of Mars just to drink and grow crops.
The energy infrastructure required for that is mind-boggling.
It really is.
But there is another idea out there to solve this. An idea championed by astrophysicists like Neil deGrasse Tyson that sounds like pure science fiction, but is grounded in actual planetary physics. Terraforming.
Terraforming is a fascinating concept. It's the theoretical planetary-scale engineering process of deliberately modifying a dead planet's atmosphere, temperature, and ecology to make it Earth-like.
And Tyson has a specific idea for Mars, right?
Tyson points out that we could potentially achieve this by placing giant orbital mirrors in space around Mars.
Let's unpack the mechanics of that. Giant space mirrors. How does reflecting light change an atmosphere?
The mirrors, which would be massive reflective sails miles across, would be angled to catch and reflect continuous, concentrated sunlight directly onto the Martian polar ice caps.
Heating them up.
Exactly. The polar caps on Mars are largely made of dry ice, which is frozen carbon dioxide. This intense, concentrated heat would melt the dry ice, causing it to sublimate directly into CO2 gas.
Oh, I see where this is going.
Right. Releasing massive quantities of carbon dioxide into the thin Martian atmosphere would trigger a runaway artificial greenhouse effect.
So the atmosphere would thicken, trapping more heat from the sun, eventually raising the global temperature enough for the subterranean water ice to melt and flow on the surface again as liquid oceans.
That is the theoretical mechanism, yeah.
You would be artificially recreating the exact climate change disaster we are desperately trying to stop on Earth, but doing it on Mars on purpose to jumpstart a dead planet? That is wild.
It's an ironic twist on planetary management.
But as you mentioned, the technology and the timeline for terraforming, we're talking centuries, maybe millennia, make it a distant dream. Now we've explored the hard, peer-reviewed astrophysics. But this deep dive promised to look at all the sources. We have to look at the alternative theories, the incredibly resilient conspiracies that simply will not die.
This is a very revealing area of discussion.
Because as we dive into this next phase, examining the wild side of Mars, I think there's a lot to learn about human nature.
I completely agree. Examining why people believe these theories is just as important as analyzing the facts themselves.
It tells us about ourselves.
It reveals how our brains process ambiguous information, how we construct narratives out of noise, and how deeply, almost desperately, we desire to find meaning and connection in a vast, uncaring universe.
Exactly. So let's start with Theory 1. The face on Mars and the Cydonia complex. We talked about how the Mariner 4 flyby shattered the canal illusion. But in 1976, a new orbiter arrived, right?
Yes, the National Aeronautics and Space Administration sent the Viking 1 orbiter to map the planet for potential landing sites.
And it flew over a region called Cydonia, snapped a picture, and sent it back to Earth. And there, staring back up into space from the dusty surface, was a massive, perfectly proportioned, haunting human face.
It was a very striking image.
The agency released the photo, and a scientist named Gerald Soffin immediately dismissed it during a press conference as a simple trick of light and shadow on a natural mesa. But the public did not buy it.
They absolutely did not buy it. The pushback was intense and sustained for decades.
But people actually analyzed the raw data, didn't they?
Yes. Two computer engineers, Vincent DiPietro and Gregory Molinar, actually acquired the raw digital data tapes from the agency and digitally enhanced the photos using advanced image processing algorithms.
What did they claim to find?
They presented their refined findings, arguing the symmetry of the eyes, nose, and mouth was simply too perfect to be wind erosion.
And that sparked a whole movement.
It caught the attention of an independent researcher named Richard Hoagland, who took the theory even further. Hoagland didn't just see a face. He analyzed the surrounding terrain in Cydonia and claimed he found an entire ruined city.
Yeah, the Cydonia complex. He found what he called a five-sided pentagonal pyramid and a fortress-like structure.
He claimed they were aligned mathematically.
Right. He said these structures were aligned with mathematical, geometric precision, mirroring the layout of monuments in Washington, D.C., or the pyramids in Egypt. And the theory didn't die in the 70s. It kept evolving.
The theories always adapt to new imagery.
Decades later, a researcher named George Haas looked at newer, higher-resolution satellite images and found massive, distinct keyhole-shaped structures on Mars. He pointed out that these keyhole shapes are visually identical to ancient man-made tomb structures found in Japan and the deserts of Saudi Arabia.
The visual comparisons are quite dramatic.
Even astronaut Buzz Aldrin, the second man to walk on the moon, went on national television and openly questioned the origin of a perfectly rectangular 300-foot-tall monolith sitting completely out of place on the Martian moon, Phobos.
The visual correlations in those low-resolution photos are certainly striking, which is exactly why the theory endures so stubbornly. But the scientific rebuttal to all of this relies on evolutionary biology, specifically a psychological phenomenon known as pareidolia.
Pareidolia. We touched on this concept briefly when talking about Percival Lowell mapping his own eyeball, but let's unpack it deeply for the Cydonia face. Why do our highly evolved brains insist on seeing a carved face in a random pile of rocks?
Pareidolia is a survival mechanism deeply hardwired into human evolution.
How does it help us survive?
Our ancient ancestors survived by being hypervigilant pattern recognizers. Our brains have a highly specialized region called the fusiform face area, which is dedicated solely to identifying faces.
Okay, so we're programmed to look for faces.
Exactly. If you were a primitive human walking through the jungle at twilight, it is much safer for your brain to mistakenly identify a random shadow in the bushes as the face of a hidden predator than to ignore a pattern and be eaten.
Better safe than sorry.
We are biologically programmed to find familiar shapes, especially faces and random noise to keep us alive. A false positive is safe. A false negative is deadly.
That makes total sense.
So, when we look at a low-resolution satellite photo of a heavily eroded mountain with shadows cast at a very specific 20-degree sun angle, our brain immediately connects the dots and screams, "Face!"
It's just doing its job.
Right. Later, ultra-high-resolution photos from the Mars Global Surveyor, taken from different angles and different lighting, prove definitively that it is just a highly eroded natural mesa. But the evolutionary quirk of pareidolia makes the initial illusions incredibly difficult to shake.
Okay, so maybe the face is just a trick of our evolutionary hardwiring acting up. But what if the connection between Mars and Earth isn't just a trick of the light? What if it is historical? Let's move to theory 2. Martians built ancient Earth.
This is a very expansive theory.
Let's go back to 1845. An archaeologist named Austin Henry Layard is excavating the ruins of the ancient Assyrian city of Nineveh in modern-day Iraq. He unearths this massive ancient library containing 30,000 cuneiform clay tablets.
The creation tablets.
Yes. When scholars translated the creation tablets, they found incredibly detailed stories of powerful beings called the Anunnaki. Now, mainstream historians view this purely as mythology, translating Anunnaki as gods from the pantheon.
Which is the standard academic interpretation.
But alternative theorists, like the ancient astronaut proponents, argue this is a fundamental mistranslation. They claim Anunnaki literally means those who from heaven to earth came, or sky people.
Right, taking the text completely literally.
And they argue that these tablets literally describe biological beings arriving from Mars in winged circles to teach humanity mathematics, agriculture, and how to build civilization.
It is a very compelling, sweeping narrative for those looking for extraterrestrial intervention in human history. And these theorists extend this logic directly from Mesopotamia to ancient Egypt.
The Egypt connection is wild.
They often point out an intriguing linguistic coincidence. The Arabic name for the city of Cairo, Al-Qahira, translates roughly to the place of Mars, or the victorious.
The place of Mars?
Yes. They use this etymological link to bridge the gap to the construction of the Great Pyramid of Khufu.
Right, because the Great Pyramid remains a logistical nightmare that baffles modern engineering. I mean, it consists of roughly 2.3 million stone blocks, some weighing up to 50 tons each, quarried miles away.
It's an architectural marvel.
And the Egyptians supposedly cut them with copper tools and built it in 20 years without even using the wheel for transport. Alternative authors like Graham Hancock suggest this is physically impossible for ancient humans using brute force and ramps.
So what do they propose instead?
They propose the Egyptians must have used advanced extraterrestrial techniques like acoustic levitation to float the massive blocks into place. There are even deep-seated legends suggesting the first brilliant architect of the pyramids, Imhotep, received his vast knowledge from a deity named Thoth, who ancient astronaut theorists claim was actually an extraterrestrial engineer.
And the alternative theories regarding the pyramid's actual purpose are equally unconventional.
Oh yeah, like the water pump theory.
Exactly. For example, an engineer named John Cadman proposed a highly technical theory that the pyramids were never intended to be tombs at all. He points out that no original mummy was ever actually found inside Khufu's pyramid.
So if it wasn't a tomb, what was it?
He theorized they were massive water pumps. According to Cadman's research into fluid dynamics, water from the Nile was flushed through the subterranean chambers, creating rhythmic, violent hydraulic shocks, like a massive ram pump.
And the shocks did what?
He argued these shocks generated acoustic and microwave vibrations, essentially turning the entire pyramid structure into a massive energy transmitter.
Sending microwave signals out into space. But the theorists don't just stop at ancient engineering. They look closely at human biology, too.
The biological claims are very popular.
They point to the Egyptian pharaoh Akhenaten, who is depicted in all his statues and carvings with this dramatically elongated, almost alien-looking skull. They say, look at the statues. That is not a human skull. That is a human-alien hybrid.
Which physical anthropologists and archaeologists firmly debunk.
How do they explain the skulls, then?
The elongated skulls found in Egypt, and in South America for that matter, are the result of artificial cranial deformation. It is a well-documented cultural practice where an infant's soft skull is tightly bound with wood and cloth to shape its growth over time. It was often done to signify nobility or elite social status.
So it was just a body modification trend?
Yes. However, the biological arguments of the theorists don't end with skull shapes. They dive deep into modern genetics to find their proof.
Yes. This is where the science gets really thought-provoking. In 2007, a major study from the University of Wisconsin showed that human DNA was evolving 100 times faster 5,000 years ago than at any other time in history.
Which coincides with the rise of civilization.
Right around the exact time these massive ancient civilizations in Mesopotamia and Egypt were inexplicably exploding into existence. And then a 2020 study out of the University of California, Los Angeles found ghost DNA in modern West African populations.
That's DNA.
Yeah. They found genetic code from a completely unknown, unidentified hominid ancestor that entered our gene pool 50,000 years ago. Theorists look at that sudden rapid evolution and that unidentified ghost DNA and say, boom, alien genetic manipulation.
While mainstream geneticists attribute that ghost DNA to an undiscovered terrestrial hominid cousin, similar to Neanderthals or Denisovans, there is actually a legitimate, peer-reviewed scientific theory that supports the broader idea of our biological origins being extraterrestrial.
Wait, really? A mainstream theory?
Yes. It is a serious concept studied at highly respected institutions like Harvard University, and it is called panspermia.
Panspermia, seed everywhere. Break down the mechanics of this for me.
Specifically, lithopanspermia. It is the hypothesis that the basic building blocks of life extremophile microbial organisms, or complex amino acids, exist throughout the universe, and they are distributed by meteoroids, asteroids, and comets.
Okay, so life hitchhiking on rocks.
Exactly. If we connect this to our earlier discussion, we know definitively that Mars had oceans and a thick atmosphere 3 billion years ago. We know pieces of Mars have been blasted off by asteroid impacts, and survive the journey to land on Earth.
Like the ALH 84001 meteorite from Antarctica.
Exactly.
Yeah.
So if a comet hit a fertile microbe-rich Mars billions of years ago, the kinetic impact could have ejected a chunk of rock carrying living Martian microbes deeply embedded inside it, shielding them from the radiation of space.
Oh, wow.
That rock floats through the vacuum, crashes into a young, hot, lifeless Earth, and the microbes survive the impact to seed our oceans with life.
Which means the entire evolutionary chain, from amoeba to dinosaurs to humans, started on Mars. We might literally biologically be the descendants of Martians.
Under the rigorous framework of lithopanspermia, it is a scientifically plausible scenario. Microbes are incredibly resilient. We find them on the outside of the International Space Station, surviving the vacuum of space. This theory grounds the wild alien ancestor concepts in actual astrophysics and microbiology.
That is heavy. But we promise to go all the way down the rabbit hole. And at the very bottom of that dark hole is Theory 3. Nuclear war and secret space marines.
This one is quite a leap.
I have to tell you about a man named Randy Kramer. This is an individual who came forward with a tale that sounds like the script of a blockbuster sci-fi movie.
What did he claim?
Kramer claims that as a child, he was drafted into a covert, ultra-classified United States Marine program called Moonshadow. He says he was eventually teleported via advanced jump room technology to a top-secret military base on Mars called Ares Prime.
Ares Prime.
Yeah. According to Kramer's elaborate narrative, he spent 17 years fighting a brutal interstellar ground war on the Martian surface, fighting alongside two highly advanced indigenous underground Martian species to defend the planet against hostile reptilian alien invaders.
It is, without a doubt, a highly fantastical narrative, completely lacking any documentary, photographic, or physical evidence.
Yeah, totally zero proof.
However, what makes Kramer's story fascinating from an analytical standpoint is not the teleportation, but the bizarre grain of actual hard science that his supporters use to anchor the tale and give it a veneer of credibility.
Right. The nuclear evidence. When I first read about this, I couldn't believe it was real data.
It is real data. A physicist named John Brandenburg published research highlighting a highly anomalous chemical signature on the surface of Mars. The Martian atmosphere and the surface soil are heavily enriched with an isotope called xenon-129.
Let's slow down and explain the physics of that. What exactly is xenon-129, and why does finding it on Mars matter?
Xenon-129 is a highly specific, unstable isotope. On Earth, we typically only see high concentrations of xenon-129 in very specific, highly destructive circumstances.
Like what?
It is produced in the immediate aftermath of a massive nuclear chain reaction, specifically the fission of uranium-235. It is found in abundance in the radioactive fallout at the site of the Chernobyl nuclear disaster and at the ground zero sites of atmospheric nuclear bomb tests. Brandenburg argued that the sheer volume of xenon-129 globally distributed on Mars could not be natural and must be the signature of massive ancient thermonuclear explosions that wiped out the Martian civilization.
So the conspiracy theorists point to Brandenburg's peer-reviewed xenon-129 data and say, see, Randy Kramer is telling the truth. There was a literal nuclear war on Mars, and the military is still up there fighting.
That's how they connect the dots, yes.
If we are looking at a chemical signature that on Earth means a nuclear bomb went off, how does mainstream science debunk a literal nuclear fallout signature?
Mainstream astrophysics provides a powerful counter-theory rooted in natural rather than artificial devastation. They point to historical terrestrial events, specifically the 1908 Tunguska event in Siberia.
The Tunguska event. This was a massive explosion in the middle of a desolate Russian forest that knocked people off their feet miles away, right?
Exactly. A massive natural meteor, roughly 150 feet across, entered Earth's atmosphere at a shallow angle. The immense friction and pressure caused it to heat up rapidly, and it detonated in what is called an airburst, roughly 3 to 6 miles above the ground, before ever hitting the surface.
So the meteor just exploded in the sky.
Yes. The force of that natural explosion leveled 80 million trees over hundreds of square miles in a radial pattern. It detonated with the explosive yield of roughly 185 Hiroshima-sized nuclear bombs.
185.
The incredible kinetic energy released by a meteor airburst of that magnitude creates such intense heat and pressure that it can actually trigger localized nuclear reactions in the atmosphere.
Really? A rock can do that?
Yes, leaving behind radioactive traces and isotopes like xenon-129 entirely naturally without any fissile material or artificial bombs. So the Xenon 129 on Mars is far more likely the result of millions of years of cataclysmic asteroid impacts than an interstellar nuclear war.
Man, science always comes in with the grounded, rational explanation. But honestly, even the grounded explanation, a natural rock exploding in the sky with the devastating force of 185 nuclear bombs, is terrifyingly awesome.
It's a violent universe.
We have covered an immense amount of ground today. From the dining room table precision of the Mars Reconnaissance Orbiter mapping ancient rivers, to the massive political tug-of-war over an $11 billion bag of rocks.
It's a huge story.
We've traced how a simple misunderstanding of Italian grammar created a century of science fiction, and how our own evolutionary quirks, hardwired to keep us alive in the jungle, make us see faces in the dusty mountains of Cydonia. But I want to pull everything together and bring you, the listener, right back into the room with us for a final thought.
I think that's important.
If we think about the Harvard theory of lithopanspermia, if that theory holds true, and if those microbial leopard spots that Joel Hurowitz bet $20 on at Cheoff Falls actually hold the ancient biological seeds of Earth's biology, what does that mean for the future of humanity, especially as we plan to go back there?
It creates a massive, almost unsolvable ethical dilemma.
How so?
Well, if we follow through on Elon Musk's ambitions or Neil deGrasse Tyson's terraforming ideas, if we place giant mirrors in orbit, melt the polar ice caps, thicken the atmosphere, and introduce Earth microbes to jumpstart agriculture, we will fundamentally, irreversibly alter the planet.
We'd be overwriting its history.
Exactly. By trying to bring Mars back to life, we might completely contaminate and destroy the pristine 4-billion-year-old fossil record of our own origins. We could destroy the very answers we have spent centuries looking for, just as we finally reach out to touch them.
That is a thought that is going to keep me up tonight. In our desperate rush to build a second home, are we going to pave over the greatest archaeological site in the universe?
It's a profound question we have to answer before we land.
Thank you so much for joining us on this massive journey across billions of years and millions of miles. It has been an absolute thrill to unpack this with you. Before you go, a final cordial greeting and a quick reminder. If you want to help us keep exploring the deep mysteries of our universe, please support the deep dive by using the PayPal link in the description below. And make sure you follow the deep dive so you never miss an exploration into the incredible stories that shape our world. We will see you next time.